to this class. Let's try to solve this last 3 years past question on inorganic chemistry, as you can see in front of you. Let's have these two questions and let's see what we get. The one says this video is meant for every chemistry student, for JAM and WAEC candidates. So follow up with this our what's it called, the solving of these problems. So if you're also interested in watching our previous JAM class and WAEC classes, you can check our what's it called, our playlist. You see over 100 plus videos on both chemistry and physics, and chemistry and physics and mathematics for JAM and WAEC students. You can check there. You see full tutorial courses on those topics, right? So we treated for the last 10 years past question on those videos. So follow up with that classes there. Let's solve this problem here. The question says a hydrocarbon X with a molar mass of 26 consists of 29.3% of carbon. What is its molecular formula? By the way, what to find for molecular formula? So what we know before now, solution. We know that empirical formula times n will give molecular formula. So I have this. So know this. We record this last class. So by the way, if you don't know how to, if you don't know the concept behind empirical formula and molecular formula, do it to watch our video, right? I'll drop a video in the description of this video. Like I'll drop a link to the introduction to empirical formula and molecular formula concept in the description of this video. So watch that first before you dive into this, so that to further solidify the understanding of this. So empirical formula times n will give molecular formula. If it is true, let's get empirical formula, let's get n, so that we can easily get molecular formula. Let's get the empirical formula, please. So at this point, calculating for empirical formula. Now we said when it comes to getting your empirical formula, go back to your question. Identify the element first. The compound is what? Hydrocarbon. So carbon comes first before hydrogen. Identify the element. Carbon, hydrogen, no problem. Now next time is that I'll divide the given mass of the element or the percentage composition by their relative atomic masses. This carbon and hydrogen, in this case here, are we given the mass or the percentage composition? Of course, I'm given what? Their percentage composition. Look up for this one now. This is for carbon. Carbon, this consists of this 29.3% of carbon. So carbon is what? 92.3% of carbon. Hydrogen is what? They didn't give us hydrogen. But mind you, the concept behind percentage composition is that everything sum up to what? 100. So if it is 92.3%, what's left? So I'll subtract 92.3 from 100. I'll have 7.7. So it becomes what? It's 7.7%. So in this case here, I am given their percentage composition, not their mass. So I'll divide each of them by what? Their relative atomic mass, who is a constant. For carbon, what's the mass? 12. What's the mass of hydrogen? That's 1. So I don't need to write this out percentage, just for teaching sake. That's why I wrote it now. So I have this. So write out the percentage composition and remember about their relative atomic mass, which is a constant. So I have this. Divide 92.3 by 12. I have 7.7. 7.7 approximately. This one too will give you 7.7. In this case now, we said after dividing each of them, so after writing out your compound, and your percentage composition, and also dividing it by their relative atomic mass, you have an answer. I'll divide this answer by the smallest one. Since this and this are the same thing, so I'll divide it by itself, divided by 7.7. 7.7. This will give 1 So I'll have a 1 concept. What does it mean now? It means that the empirical formula is equal to carbon is 1, so that's C1, hydrogen is 1, H1. This will give CH. That's all. So my empirical formula now is what? CH. But I'm told to find what? Molecular formula, not what? Empirical formula, please. So how do I get my molecular formula? We said to get molecular formula, simply multiply empirical formula, which is this, right, by n. So we first get n first and multiply by empirical formula. So how do you get your n? Now how do you get your n? That's the tax. So for n, so to get n, now, the task now is simple. We said for you to get n, what's the condition? What's the task? The task now is that I will find the relative molecular mass of this compound, right? Multiply by n and equate it to the what? To the given relative molecular mass. So what I'm saying is that to get n now becomes relative atomic mass. By the way, calculated relative molecular mass, right, times n is equal to the given relative molecular mass. That's all, please. So to get my n, I'll calculate for relative molecular mass of what compound? Of this compound, right? So times n equal to what? Given relative molecular mass, which is what? 26 in this case here. Now for the calculated one here, I have CH. By the way, C is 12, right? Plus hydrogen there is just 1. So I have 1 here into n equal to the given is what there? The given is 26. So I have 26. This gives 13 n equal to what? 26 divided by 13 by 13. What's n? N is equal to 26 divided by 13. I have about 2. This 2 here. So I have my n now is 2. So to get my molecular formula is quite simple now. So molecular formula now is equal to what? Empirical formula is CH. That's CH, right? Times what? Times n. What's n now? N is 2. So expand this. This is C2, H2, H2. So my answer becomes C2H2. So C2H2, that's what? Answer question number 1 is my answer. So this C2H2 is my molecular formula of this compound. Let's do example 2. If the vapor density of an organic compound is 78, calculate its molecular formula. So in this case here, I'm given the vapor density, right? So note that we said there are 2 formulas for calculating molecular formula. We said the first one is that solution. Before I solve this, note 2 things, please. We said empirical formula times n equal to molecular formula. I can get molecular formula using this. I can also get molecular formula by what? Multiplying 2 by vapor density. This is another formula for calculating molecular formula, right? So molecular formula is equal to what? 2 times what? Vapor density. So now I'll be using what? Which one will I use? Is it equation 1 or 2 to solve this? Of course, I'll use what? Equation 2 to solve this. So it means that my molecular formula is equal to 2 times what's the vapor density given? That's 78. So it means that my molecular formula is equal to 2 times 78 there. I have 156 gram per mole. So this is my answer to this particular. Observe the option I gave you. This one should be there. That's question option A. So this is my answer to this particular question here. So if you found this class helpful, do well to share to your friends and classmates. Subscribe to my channel, share to your friends and classmates on my channel, like the video, leave a comment, and see you in the next class.